Okay, great. Let's start. It is the homework for lab portion. This is going to be our first time where I just walk through the steps of the homework. Please stop me if you have any questions about anything that happens. Do we have any other questions before I get started? Cool.
Homework. Oh, no. Sorry.
First things first. Actually, I'll just set this back to what it was. I'm going to knit the document. Oh my goodness. I have yet more packages to load. For those who are watching this not live, I don't have my computer, and this computer that we're on doesn't have all the packages loaded. Okay, so when you first get your homework, it's going to look like this. Here we'll have some instructions. For this assignment, you'll be practicing creating, examining, and combining different data structures in R. This assignment is different from others in that it takes a worksheet format with built-in error checking. And as some of you have already emailed, the error checking is not perfect. Each time you complete an answer, if you knit the document, it should check your answer. But do not remove null on an answer before you want it checked, or you'll get an error. For this reason, you should re-knit every time you answer a question, so that if it goes wrong, you know the last edit caused the issue. You'll need to do the following. First, fill in the code as needed in the designated locations and code chunks. You will not need to create new code chunks or edit chunk options. Instructions and chunk options will be shown as comments. Remove and replace the comments with your code. Where you are assigning things to objects, replace the null values with your code. See code example 1 for an example. That is down here. This is what the problem will look like, and you will write something like this. You may need to add elements such as subsetting to objects on the left side of the operators. See code example 2 for an example. So add the number 10 to the 6th position of example 2. So here you would write to the 6th element of example 2, assign the number 10. Some answers may require multiple lines of code, so add as necessary. Do not modify chunks labeled with hashtag do not edit. These are used to test your code. Second, fill in text as block quotes using the greater than in designated locations to answer questions. Be brief and specific. If you referenced a single value or short less than 10 element vector, use inline R code. If the answer can be clearly and accurately answered without referencing any values, you can do so. When I bold a word in question, take it to mean I want you to reference a value or values. Do not directly reference matrices, lists, or data frames in text. What I mean by that is don't display them, as they can be big. You should not need to include any code chunks in this section, but can if you need. An example of the text questions is here. How do atomic vectors differ from lists? And then because this bar is here, we know that they have already used the greater than. An atomic vector is one-dimensional object where every element is the same type of data. Lists are one-dimensional, but element can be used or can be different data types. Note that for this walkthrough, I will not be answering all of the text questions. I'm happy to field questions about them. I will not be answering them all. Otherwise, somebody watching the video could just copy it and not learn anything. So let's get started. Our first question is, use the sequence function to create a vector of 10 numbers evenly spaced from 0 to 15. And if you'll recall, I gapped during class last week answering the same question. So here, what I'm doing is saying sequence from 0 to 15 for a length of 10 numbers. And when we knit that, good job on vec node. Great. Question number 2. Use the colon to create an integer vector of the numbers 11 through 20. So we're going to assign to vec int the numbers 11 through 20 using the colon operator. Recall that this will assign or count by integers. Is this not automatic update? Oh no, we good. For question 3, use all caps letters, the built-in vector in R, and the single bracket subset operator to create a vector of the last 10 capital letters. And so since we know already that the letters data set or vector will just count the English alphabet in all caps, we can say letters 17 through 26. This is subsetting to just the 17th through 26th elements of the letters vector. Great. Number 4, use letters and the subset operator to create a factor variable using the first 10 lowercase letters. Okay, this one's a little bit more complicated. So we're going to use the lowercase letters vector, and then we want to subset to the first 10 lowercase letters, so 1 through 10. And then we also want it as a factor, so we can say factor and wrap it like that if we want to use our base R methods. Cool. Note that when we look at this vector, it tells us the levels. This is how we might, in a glance, know that we're dealing with a factor vector. Whereas if we look at vec cha, you would see that it's a character as all of the letters are in quotes. Question 5, use the concatenate function to combine vec cha and vec fact into vec let. Do not convert it to a factor. Okay. So we'll use our concatenate function to combine vec cha and vec fact. And let's just real quick before we. Okay, so now we can see at a glance that our combined vector has turned everything into characters, and that we've lost some information. The vec fact was a factor with these 10 levels, but what happened when we combined them is that we only got the underlying numbers assigned to those first 10 elements. Now I'm going to knit to check if I got the right answer. Good job on vec. Good job, team. Number 6 says, use the concatenate and subset functions or subset operator to combine the first 4 elements of vec num with the last 4 elements of vec int to create vec ni. Okay, so now we're using the concatenate. We want the first 4 elements of vec num. So we could say vec num 1 through 4 and vec int 7 through 10. Okay, we got that one. I do want to point out an alternative way that I really enjoy that you could do for this is to say concatenate vec num to we'd probably still keep this, but we could say vec int length vec int -3, I think. I'm confusing myself. I can't recall that answer off the top of my head, and I'm sorry. But one thing I will note is that I find it very difficult to code live and remember how to do everything. So that'll happen from time to time. And what you'll get are happy accidents. So for number 7, use the rev or reverse to reverse the order of vec fact. So reverse fact. And down here, we take a look at it. And we'll see that the levels are the same, but the order of the elements in the vector have been reversed. Great. That's section 1. Do we have any questions about that? That was coding with vectors. It's okay if it knits just perfectly fine. I'm only showing stuff in the console just for it to be shown so that you can see it.
Scroll up to the top. Look at the top.
Just the top of this chunk.
Keep going to where it says double. That's
Coding with atomic vectors. Yes. Of course. Yes. Mm-hmm.
So when I run that,
When you run like this, when you run it, what this is saying is here we have a vector and its elements are j through a. And then down here we have its levels, which are saying that like A is assigned to number 1, B is assigned to number 2, and so on through 10. So like I said, we're moving past the questions about vectors. Have fun working on those on your own. So section 2, coding with matrices. Our question 1 here is use the matrix function to create a matrix with 10 rows and 4 columns filled with NA. Here we will use the matrix function. I like to say NA here. Then our number of rows is equal to 10, and our number of columns is equal to 4. Okay. Looks like mat empty is correct. If at the end you have a matrix that prints out like this, we'll know you're in good shape. Question 2, assign vec num to the first column of mat 1. Note, you do not want to edit this line, add the code below it. So we're going to add to the first column. We will actually need, this will be the first example of having to go over to where we're assigning. And recall that it goes rows on the left of this comma and columns on the right. And so we're looking for the first column. So here's how we might denote the first column here using our subset operator. And if you need a quick example, looking at a matrix, it actually keeps this same syntax. So we know that our first column is this subset comma 1. This will be this column. We want that column to take on the values of our vec num. Oh. Yes. And we'll see that it has taken on these columns of our vec num. Let's see if the checker also thinks that. Big shout, computer. For question 3, assign vec int to the second column of matrix 2 below. So let's see, we want to assign to the second column of matrix 2. We'll keep the same syntax of putting nothing in the row space, comma, 2 to denote the second column of our matrix. And we're giving it vec int. Good job with that. And if we want to see what it looks like, check mat 2 down here and see that we have our vec num in column 1 and our vec int in column 2. For question 4, we're going to assign vec cha and vec fac to the third and fourth columns of matrix 3 using one assignment operator. All right. So we're still working with columns here. So we're going to put nothing in the row space, comma. And then for our columns, we need the third and fourth one. So recall that we can actually supply a vector in order to subset. So here we're going to say concatenate 3, 4, and this will give us our third and fourth columns. let's see, we want to get columns. We probably want to use cbind. We'll have veccha and vecfac as our arguments. Do we have any questions there? I know that this is kind of a lot relative to our other questions. Yes.
Sorry, we just got here. I'm just wondering, like.
I see. We are walking through each question step by step, and we're already in the second section, coding with matrices.
Are you going to be sharing?
Yes, this video is going to be going out tonight. I will not be sharing the text of this document, as that would just give all the answers, and I want people to work through it at least a little bit. The text, I mean like the script, like I'm not going to supply this document that I'm filling out right now to the website. Yes. Well, I mean, we're having it live, but I'm not going to post it. So do we have any questions on number 4? Okay, great. For number 5, we are going to select the 4th row from matrix 3 and assign it to the object row 4, or assign it to the object row 4 as a vector. Okay. So we're going to assign the 4th row of matrix 3. And here we're going to put 4 on the row side of the comma and nothing on the column side of the comma. And recall, when you take just a row of something out of a matrix, it will already know that you just want a, oh snap, I see, I got off track there. It will supply back a vector instead of a matrix itself. If you wanted a matrix, you would say drop equals false. Great, we got mat 3 in row 4. For number 6, we want to assign the element in the 6th row and 2nd column of matrix 3 to value 6.2 as a numeric value. Okay. See, we have matrix 3, and we want the 6th row and the 2nd column. But it also says as a numeric value. So let's see if we don't do anything. When we say class val 6.2, it's a character. So one way we could convert this to a numeric value is to wrap this whole subset in as.numeric. And now when we check again, you'll see that this number 16 is not in quotes and therefore is not a character string.
So it was just string, like shape, not
Correct. Actually, I can give an example. So if we said this plus 5, it would yell at us. Okay, keep on trucking. Question number 7, use cbind to combine our numeric vector, our integer vector, our character vector, and our factor vector into matrix 4. Okay, just gonna put those in order. I don't see why that wouldn't work. I tend to, when it comes to lists of anything that's more than like 2 or 3, hit enter after the comma because I find that it's easier for me to read and understand what's going on in there. But you don't have to do that.
Can you just hit C? Not C bind?
It would not print out a matrix.
C bind is for me.
Yes, and C would give you a vector back. Mhm. Yes.
Moving into here, and on a line that I'm not even on, it's giving me for line 204 error and it's tracking the X. Tracking what correction. It was on line question 4 when it popped up.
You're on question 4 when it popped up.
Mm-hmm.
Let's see here. Perhaps if you just like Control Z back to before you typed in question 4, what is it like? Was it still giving you such an error when you knit?
Yeah. I'm gonna try. Maybe I'm checking my lines too.
Okay.
It's exactly the same, but still that error.
Okay. I would like to continue with the walkthrough. I can help you in specific after class.
Okay. Template it has a line 189.
I'm sorry? You're talking about this question, like things like this. 182. Do not edit this line. Add code below it.
Yeah.
Yeah, I have been like hitting enter in things in places, so they might be like slightly ajar.
So if we haven't been able to like follow you at this point, like are we trying to like go from where you're at now, but that's
I mean, I wouldn't think that it's impossible. Where are you? Like, what is the last object that you assigned and it knit correctly? Okay, so here. Okay, we're good. But I now see why I should probably not put these like that. Question. Object mat. Mat 3 was not found. Perhaps this was after you knit. Did you manipulate this line in any way? About what line 182? It should be right under number 4 in the section 2 coding matrices. Perhaps there's like a comma splice somewhere. Did you have the answer for matrix 2? Like, are these previous ones also correct because they build on each other? But when you knit, are they saying good job on each of the preceding ones? Sure. Three not found. Do you have these objects?
Mm, I think so. I don't know.
They would have been like from up here.
Yeah, they should be there.
Okay. And 3. This doesn't have an underscore here.
I don't know why.
I see. There's a missing underscore here.
Okay.
Okay,
Thank
cool.
you.
Of course. Okay, great. Where were we at? Okay, so we C-binded these 4 vectors together to get matrix 4. And it should look something like this. Okay, great. Next, we want to make matrix T. Question 8 says, next, first transpose matrix 4, then select only the first 4 columns and assign it to matrix T. Okay. I think that we can take that one at its word and say, all lowercase t, the function means transpose. And we can subset straight from here and say 1 through 4 to give me the first 4 columns. Actually, I need to say comma. I forgot to say nothing for the row space, comma, 1 through 4 for the column space. You'll see the relationship here between these 2 matrices. The transposition, so like what was a column in this matrix is now a row in this matrix. And that it was flipped along its diagonal. Okay. Do we have any questions on number 8? Seeing some shaking heads. Let's move onward. Number 9. Then use rbind to add rows from matrix 3 to this. Something like matrix T first, matrix 3 second, and assign this combination to matrix big. R bind mat T, then comma space mat 3.
Bind it, column bind, not.
Yes. You'll note our matrix big is in fact pretty big relative to our other matrices, and that we have stacked matrix 3 to matrix T. Great. Now I can move on to lists. That means that they are characters. Why are they not numbers? It's because if anything in your matrix is of a like lower level character or type, then everything in your matrix has to become that, because matrices are only one type, and characters can contain both text strings and numbers. Cool. Do we have any other questions? Excellent. All right, section 3, lists. Question 1 here says use list to create a list that contains vecnum and row 4, and assign the names vecnum and row 4 to these two elements of list 1. Great. So we will use the list function, and we will say vecnum equals the vector vecnum. So here we are actually specifying the name of the element in our list. And then we'll say comma, row 4 equals our vector row 4. Now, when we check out what our list 1 contains, we'll see that we could extract vecnum, and vecnum would return a vector with these elements, and we could extract row 4, and it would return a vector of these elements. Okay, number 2, using the extract operator, extract row 4 from list 1 and assign it to the object row 4 2. So let's see, we would say list 1, use the extract operator, and we want row 4, and we are going to assign it to row 4 2. If you look at row 4 2, we'll see that it's the same elements as the row 4 vector that we had originally. Looking good. Number 3, create another list that contains values 6 2 and matrix big. Okay. This one didn't say that we had to assign names to it, so I'm just going to say list value 6 2, comma, that big. We'll see that list 2 has in its first element our value 6, 2 here, and in its second element, our whole matrix big. On number 4, combine list 1 and list 2 together using the concatenate function and assign them to list 3. Should look something like this. Great. Number 5 says use the unlist function to turn list 3 into a vector and assign it to vector 3. So sort of in the question, it explains what unlist does. The unlist function turns something that is a list into a vector. So we'll unlist list 3. We're going to assign it to the object vector 3. Go down here and check. Vector 3, we'll see we'll get back the contents that we had for.
We'll see to get back the context that we had for vector 3, right?
From the inside of list 2,
Oh, okay.
or the inside of the combination of list 1 and list 2 that we had from question 4. Okay. For number 6, use the as.list function to convert vector 3 into a list and assign it to list big. As.list. Apply the argument vector 3. Okay. Question. Okay.
Well, why would you need to like this stuff with
Would I ever need to have something in a list, unlist it, and then put it back into a list? Sure. I can give you an example from a problem I had in research recently where I was scraping all of the unfair labor practice lawsuits by unions. And so what I was doing is I was saving them into a list because some of the materials was a bunch of weird text and some of the materials was like very explicit, like ballots and things and all that kind of stuff. And so it was all over the place. And so I wanted to save it into a list because I knew it could handle it. And then I used unlist to take out just the ballots. So like that allowed me to use like dplyr syntax to like manipulate the ballot things. And then I put it back into a list because it was easier for me to port that to my like colleagues. Right. Yeah, and you want to use lists because of the flexibility it affords you for what kinds of objects it can store. But also the reason that this is like, we made a list, we unlisted it and then relisted it. It's just so that you can see where each of the pieces go. Let's see. Number 7. Now copy list 3 as list 4 and use the double bracket subset to assign list 3 as the last, the 5th element of list 4. That is, you should have a list object with 5 elements named list 4 that contains the same 4 elements as list 3 plus a 5th element that is all 4 elements of list 3 as one object. Okay, so let's take it one thing at a time. Now copy list 3 as list 4. I think that suffices. List 3 was just assigned to list 4 straight up. And then we want the 5th element to also be all of the contents of list 3. So we'll say list 4, double bracket, the number 5 for the 5th element, and then assign it also list 3. Are we cool with what's going on here? Yes, this is the number 5 here inside of the double brackets. Okay. Number 8, select the 3rd element, that is the sub-element of the 5th element of list 4, and assign it to element 5, 3 using the double bracket subset. Okay, so we have list 4, and we want the 3rd element of the 5th element of list 4. Okay. So first we want to get to the 5th element. We'll use the double subset to get there, and we'll chain subsets. Note we're using the double bracket again. Although I'm not sure if it will be mad at us if it doesn't. I don't think it will. So here we go from list 4. We take just the 5th element of that, and then we get just the 3rd element of whatever our 5th element of list 4 is. Lastly, repeat the previous assignment of the 3rd element of the 5th element, but extract the element as a list rather than scalar using a single brackets and assign it to list 5, 3. So recall that we want to use the double brackets when we're subsetting from a list if we want to maintain the type of object that it was originally. But also that the 5th element of list 4 is already a list. So if you want to keep it as a list, we want to have a single bracket for the 2nd time. You'll see what I'm talking about when I type it. So list 4, double bracket to get the 5th element, single bracket for the 3rd element, and rather than returning back the underlying type that the 3rd element of the 5th element of list 4 is, it will return back a list with the same materials inside. The difference here is that this, I'll show you here. If we say class list 5, 3, we'll get a list. Whereas if we say class element, or class element 5, 3, we have a numeric. Okay, great. So that was the last of our lists questions. Do we have any questions about those?
We have like a specific question that doesn't relate to everybody else, should we just ask it later?
It depends on the nature of the question.
It's a annoying question. I apparently attempted to use a zero length variable and I can't figure out where.
A zero length variable can't figure out where.
It says line 133, but
Yeah, that was quite some time ago.
I know. It's been saying it for a while. Can I show you later?
Yes.
Okay.
Okay. Okay, let's get started with data frames. For section 4, we have data frames. Question 1 says, use the function data.frame to combine vec_num in our first column and vec_int in the second column into data frame 1. Okay. The data.frame is going to be our function. The first column will be vec_num, and the second one will be vec_int. And here is our data frame. Looks good. The second question says, use the extract operator to extract vec_num from data frame 1, reverse it with rev, and assign it to the vector vec_num2. Okay. So we are going to say, actually, if we want data frame 1, we want to extract vec_num. We want to reverse it, so we can wrap the whole thing in the reverse function. Actually, I'm sorry. Okay, so if we think about a data frame as a bunch of vectors, then extracting means we're taking just one of them, and then reverse just means we're turning it upside down. So the 10th element, or whatever the bottom one is, becomes the first one.
Oh, yes.
Yeah, yes, but transposition is for matrices. There are very few times ever that you'd want to transpose a data frame without first making it a matrix. But like transposition will be more useful with like more stats background.
And you would never do piping because we're not in block, we're doing like base R. So
we could. I know that some people do this whole assignment using like dplyr verbs and things.
Oh,
and,
okay.
so we could say instead something like
I don't really want to do it. That was like such a logical way to do it. We're just like, this is for like R for beginners. This is not base R.
that I wanted to leave that up to the user if they wanted to practice base R things or if they wanted to do this instead, because this will provide you the same answers.
But what you're teaching us is base R, right?
Yes, but that's mostly because that's the first thing that comes to my brain.
Yeah.
For these kinds of questions.
Yeah, I have no trying to understand the difference.
Let's see. Question 3 says, use the extract operator to add vec_num2 to data frame 2 as a new column with the name number vector. And now that I'm seeing this, I'm not sure that y'all have seen an example of this, maybe in like a different class, but you can actually create new columns by using the extract operator and assigning something to it. So here we're going to say data frame 2, extract, and then we're going to type our own new column name called number vector and assign it vecnum2. And what this does is it creates a new column in our data frame named number vector, and then we supply it the vector that will become the column. You would need to run the previous line ahead of it. And if we look at data frame 2 right quick, we'll see that vecnum in our first column is the same thing as our number vector column, but it's been reversed. And we just created this column by using the extract operator and handing it a new name and assigning that an object that is of equal length in our data frame. Okay, data frame 2 is looking good. Number 4, combine data frame 2 with itself using rbind to create data frame 3. One such way to do this would just say rbind data frame 2, comma, data frame 2. And what this will do is it just stacks the rows on top of each other. But if we look at our data frame 3, we'll see that it's stacked these rows on top of each other. But what's more is it's retained its data frameness. It's still a data frame. Note, like thus far, we've been using rbind and cbind exclusively for matrices, but you can in fact use it for data frames, and it will output a data frame. So it's important to know what your underlying class of object is at that stage. Okay, data frame 3 is looking good. Do we have any questions here? Question 5. Create a new data frame called data frame 4 using the data.frame function that contains the following named columns in order. Y, that contains 20 numbers evenly spaced from 31 to 125. X, that has 20 numbers between 0 and 10 generated using the R uniform or runif function. If you need help, use $runif. And also color that consists of 20 values sampled from callvec using below using the sample function. Okay, there's kind of a lot of things going on here in this one. We'll just go ahead and run callvec to make sure that that's ready to go. Well, what is runif? There is an always gnawing part of me that wants us to say run if I tell you to do this kind of thing. But it actually just means uniform. It pulls from a uniform distribution that is like a normal curve. And it allows you to generate numbers based on normal curve. So it doesn't mean runif, It means are uniform. Also, the colors function, which you might recall from maybe the first week, you run it. It just tells you all of the base colors that R has. And this is what we will be sampling from for our data frame. Let's see, what else? I think that should be it. Let's get started. So we're using the data.frame function. We want, in order, Y. It's going to contain 20 numbers evenly spaced from 31 to 125. Let's see. So we do want to do the same thing. We want a sequence starting with 31, ending with 125. And we want the length of that sequence to be 20 elements. That's going to make up the first column in our data frame. Here I'm going to say comma, hit enter, and get started on our X column. X is going to equal 20 numbers between 0 and 10 generated using our run if. And let's see. Run if is, it's going to say n equals 20. Our minimum value is going to be 0, and our max is going to be 10. I try to, when there's a function that I don't use very often, make sure that I specify what the arguments mean. This is really great for when you come back to it after some time. Otherwise, I'll forget. Whereas I use sequence a lot, so I tend not to type out what my arguments are in sequence. And our last column is going to equal color. And we are going to consist of 20 values sampled from the call vec. So we've already assigned to call vec the colors function. So it will have all of the colors in it. We want to use the sample function on call vec. And here size is going to equal 20. If you want, you could say like replace equals false so that you don't get any duplicate colors. But I think that it's more interesting probabilistically if we do get the same colors. And that should do it. So let's run it. Let's knit and see where we're at. Okay. This code here should produce a plot of those values with those colors. Looks like somebody spilled sprinkles. That's a dub. Do we have any questions about making that data frame? Cool. The fifth question says, use the cbind function to combine data frame 4 and data frame 2 and data frame 5. You can't get the plot to print. Yes. Did you run it like this here? Because right, because you're just supposed to leave it be, and when your data frame is correct, when you knit, it will produce the plot in the output. Like you don't need to run this now. And if your data frame is correct, it'll put out the plot.
box of the console?
That doesn't happen here because of the way that the homework checker is producing the output. You could run just this section, I believe, and it would run. But it's the beginning, this if is dot null thing that's checking your homework that might be producing the error. Sure. I suspect there is a extra parentheses here, maybe. There's a missing parentheses. That's what's going on here. And I think that should do it. A second. Yeah, it's just a couple of like comma splices and parentheses things. Okay. Let's see, where were we? Data frame 5. Use cbind to combine data frame 4 and data frame 2 into data frame 5. So cbind data frame 4, data frame 2, and we'll assign it to data frame 5. Okay. And then number 6, use data.frame to combine data frame 4 with data frame 2. You should also knit first and check. I see. Shouldn't have deleted that. Okay. Data frame prime looking good. We'll see. Data.frame. Data frame 4 and data frame 2. Okay, so that's the last one. I think, yeah. So do we have any questions about any of these? Do you think that, well, here's a question. Do you think that the recording's over? I think it probably is. I'll end that. It might have already ended. Oh, thank goodness.